We'll proceed in pseudo multivariate calculus. Pseudo multivariate calculus, this is the calculus we have started a new discussion, new kind of chain, pseudo multivariate calculus. Pseudo single variable calculus that people understand. Pseudo single variable calculus. Pseudo multivariable calculus. Pseudo means that if I need to find anything very complex, if I need to find anything very complex, that how I can proceed from writing a pseudo algorithm from the for a very simple case. So in that series, we have tried calculating the volume of a sphere. Volume of a sphere is round the shape. The simplest volume, if anyone think about, is the cubicle, where everything is cubical or cubical in the sense that it is a cuboid. That is the simplest in 3D. Cuboid means there is a width, there is a length, and there is a height. What is the volume of a cuboid when there is a width, there is a length, and there is a height? What is the volume in that case? Then it is height into the area. Height into the area. Now height is considered as z, whereas this area is considered as x into y, xy. So z into xy is the volume of a cuboid. Z being the height and xy being the area along the xy plane. Means we are talking about calculating the volume. We are talking about calculating the volume of a cuboid. So this is the top surface of a cuboid, and similarly this is the bottom surface of the cuboid, and then there are four sides to it. Okay, if I turn it, then this is width, this is length, and then this is the height. Okay, so this cuboid is from the xy plane. Concept is that this cuboid is from the xy plane, but idea is to calculate the volume of a sphere. Idea is to calculate the volume of a sphere. So this is a sphere for which we have to calculate the volume, and this is xy plane, and this is the top surface of the cuboid. Now bottom of the surface of the cuboid. Okay, I have a cuboid. Okay, I have the cuboid. So what is the volume of this cuboid? This is a cuboid. What is the volume of this cuboid? Now it is kept on xy plane. Now if someone sees it, then from top if I see, then there is a width, there is a length, and there is a height. There are four sides of it, and then top side and bottom side. Six sides are there. What is the volume of this? Then it is height into this surface area, into this surface area, into the height. That is z into the bottom surface area, that is xy. Z into xy. That is the volume of this. This is called pseudo code. If someone want to write the calculus formula, then start with the simplest shape. We have talked in detail simplest shape in the sense that in 2D, like we started with the, I believe in much detail we have talked, what is the length of this? What is the length of this? Is this curve? This is the curve, and what is its length? This is x-axis. This is y-axis. This is origin. What is the length of this? Then we started with this straight line. Rather than calculating the length of a curve, we started with the straight line. This is x-axis. Let's try to find the length of a straight line. Similarly, if I have to find the volume, if I have to find the volume of a sphere, Then start with the cube. Cube is simple. So in that sense, height into xy plane is the net volume. Height is z into xy. Now it will become z into xy, where z is dependent upon xy. If I see the sphere, then z equal to z square plus x square plus y square equal to a square. Z equal to plus minus square root of a square minus x square minus y square. Means z is dependent upon x and y. Okay, in that sense, we have the volume is z into xy. Xy is considered an xy plane. So this is kept on xy plane, where one side is x-axis and one side is y-axis. Y-axis and my side, this is x-axis. So this is kept on xy plane. This cuboid is kept on xy plane. Okay, now in that sense, volume is height into xy area. Okay, z into xy, where z is dependent upon xy plane. Xy plane is width into length, where height is z. Okay, what is width into length? So if it is kept like this, then this, if it is kept like this, then this is the height, this is the height, this is the width, and then this is the length. Height into width length, height z into xy. Okay, that is the volume. Now z is dependent upon xy. If we are multiplying two items, where one item is dependent upon other item, only two items. This is our research. This way of attempting any complex problem is not mentioned in any of the book. Try to find multiplication of two items or try to find division of two items. So here multiplication of two items is z into xy plane. That is the volume. So z into xy will come at d of xy. Z is the square root of a square minus x square minus y square into d of xy. D of xy. And then integration over the now x and y. Integration over the xy plane. So xy plane, if I see, okay, if I see like this, consider this is centered at the origin. Consider consider the center of this is origin. This is origin. It is kept at the center. Okay, in that sense, the bottom the bottom left corner is minus x by 2 minus y by 2, and then other side is x by 2 y by 2. If I talk in width and length, then minus w by 2 minus l by 2 to w by 2 to l by 2. So I have to do integration minus w by l by 2 minus w by 2 comma l by 2. Top is w by 2 comma l by 2 minus w by 2 comma minus l by 2 to w by 2 comma l by 2 z into xy, z into dxy, because it is integration of multiplication of two items where one is dependent upon other. Z is the square root of a square minus x square minus y square d of xy. Okay, now the concept here is, it is pretty simple. Pretty simple in the sense that the x and y, when limit we are taking, because we are integrating, the differential part is d of xy, d of xy. X is from where to where, y is from where to where. Or if I take xy plane altogether, then one point to another point. One point is minus w by l comma minus l by l, sorry, minus w by 2 comma minus l by 2. Other point is w by 2 comma l by 2. That is something that cover the full xy plane as far as this cuboid is concerned. Or if I consider this is the bottom left is kept at the origin, then it is 0 to w comma l. Okay, then someone can try calculating it. How much it will come. Anyway, that is called pseudo code. Same pseudo code I am going to apply. But what we see here is, if I break this limit 0, comma 0 to w, comma l into w and l, then width is, if I see from the top, the limit of the x-axis is w, the limit of y-axis is l, and both are perpendicular to each other. W and L are perpendicular to each other. It is considered as in a limit area is a rectangular area. In xy plane, limit area is rectangular area. I will reiterate it. We are trying to find the volume of a sphere. For that, we have taken a simplest case as a cuboid. This is cuboid. The bottom left corner of the cuboid is kept at the origin. Bottom and left corner is kept at the origin. One is x-axis, one is y-axis on xy plane. And height is z. Height into xy plane area. Xy plane area is w into L. Okay, height into x-axis and y-axis makes xy plane. Height into xy plane rectangular area is the net volume. Height is z into xy. Or if height is z and the bottom part is w into L, then z into wl. But if I see in xy plane, better it will be z into xy. Now xy plane, we are talking xy rectangular area, not x into y. Xy rectangular area into the height. Now if there are multiplication of two items, one is dependent upon another, z is dependent upon xy plane, then it is considered as case of integral calculus. Here, from here, we hook up into integral calculus. It becomes z into d of xy and limit of xy plane. If it is bottom left corner of this is kept at the origin, then 0, comma 0 to the area on the xy plane, 0, comma 0, 0, comma 0 to w, comma l, width and length, 0, comma 0 to w, comma l. This is the net volume of a cube. Okay, 0, comma 0 w, comma l, I can disintegrate into two integral where width is 0 to w and length is 0 to l. Okay, this is how it is. Now let's proceed with the sphere. So z in the sphere is the square root of a square minus x square minus y square, d of xy. Now limit here is x and y. In cubical, x is 0 to w and y is 0 to l. But if it is a sphere, then instead of this that is kept here like a rectangular region on xy plane, it makes a rectangular region. If I keep a if I keep a sphere, insert this sphere like this so that it is centered at the origin, and this is xy plane, half of it is above the xy plane, half of it is below the xy plane, and it will go and its center will be stick at the origin. In that case, the limit, if I see on the xy plane, it will be a circle. If someone see from the top, then it will be a circle. And circle means x is minus a to a. If radius is a, then y will be minus square root of a square minus x square to square root of a square minus x square. Means x and y are not independent of each other as far as limit is concerned, where in rectangular area they are independent of each other because they are orthogonal to each other. Here there is a circle, and circle y is dependent upon x. But if it is a rectangle, then x and y are perpendicular to each other. They are independent to each other. Their limit is constant. X is 0 to w and y is 0 to l. But here x is minus a to a and y is minus square root of a square minus x square to square root of a square minus x square. Because x square plus y square equal to a square for a circle. That is the problem. To solve this problem, we took another coordinate system. This is called Cartesian coordinate system or rectangular coordinate system. There is another coordinate system we took as r theta coordinate. That is called polar coordinate system. Or if I take r theta phi like x, y, z, then that is called a spherical coordinate system. So if I take a spherical coordinate system or a polar coordinate system, then analogous to x, y, there is r theta. Now consider x equal to r cos theta, y equal to r sin theta. Okay, then tan theta equal to y by x, theta equal to tan inverse y by x, where y equal to square root of a square minus x square. Okay, now if that is the case, then what about theta? Now theta is tan inverse square root of a square minus x square by x. When x is minus a, when x is minus a, then it is tan inverse 0. When x is minus a, then it is tan, I'm sorry, then top is 0 and bottom is minus a. Bottom is minus a. It is minus 0 kind of thing. When x is a, then it is 0 kind of thing. This is, means numerator is 0, denominator is minus a, and one time it is plus a. Okay, if that is the case, then tan inverse of 0 and minus 0, if someone see, it will come as 0 and pi. That is the tan inverse 0 and pi. So theta will be 0 to pi. What about r? Okay, now if we see y is minus square root of a square minus x square to plus square root of a square minus x square, or y equal to square root of a square minus x square, y square equal to a square minus x square plus y square equal to a square. Now we have taken x equal to r cos theta, y equal to r sin theta, x square plus y square equal to r square, and here we have x square plus y square equal to a square, r square equal to a square, r equal to plus minus a. Now we can change the limit as r. Now we use method of substitution in the integration. Now x equal to r cos theta, y equal to r sin theta. Now y is minus a to a, and theta, sorry, r is minus a to a, and theta is 0 to pi. This proves that theta is constant. 0 to pi means constant. R is minus a to a means it is constant. Okay, I believe it makes sense. It is very big thing I am talking now. If I have a something that I need to integrate is height into xy plane, height into the region in xy plane. The area in the xy plane into height gives the volume. Height of a sphere is square root of a square minus x square minus y square into d of xy circular plane, d of xy plane. Limit is one end of the circle to another end of the circle. Okay, that someone can consider, but I am going to make it in two parts, x and y. Then it is x is minus a to a, and y is minus square root of a square minus x square to square root of a square minus x square. If that is the case, consider x equal to r cos theta and y equal to r sin theta. If I am taking this substitution, then theta comes as 0 to pi and r comes as minus a to a. Now if I change limit of x and y, theta is 0 to pi and r is minus a to a. Both are constant. Theta is constant and r is constant. Whereas earlier x was minus a to a and y was minus square root of a square minus x square. Y is dependent upon x. Here both are independent to each other. If that is the case, then consider this is xy plane and this is theta r plane. Okay, in xy plane we have a circular region as the area. We are trying to find volume where the base is circular area and height is z. Z is variable since it is a sphere. Everywhere z is varying. Okay, in that sense, but in xy plane the area, so on xy plane the area into z is the volume. That is the pseudo code. Now in xy plane area is x is minus a to a and y is minus square root of a square minus x square to square root of a square minus x square, because that is a circle. If I want independence in the, if I want this, convert this spherical region or the area circular region as a rectangle, then I have to use another kind of function. Consider x equal to r cos theta and y equal to r sin theta. In that sense, theta will go 0 to pi and r will go minus a to a. Means it will make a rectangle region in r theta plane. This is a very big thing. Very, very big thing. We are converting our circular region on xy plane, that is the base area. When we are calculating the volume, base area into height is the volume. That circular region I converted into a rectangular region. This is theta r plane. This is theta and this is r, or this is r, this is theta, whatever it is. If this is theta, then theta goes from 0 to pi and r goes from minus a to a. This forms a rectangular region in theta r plane. That rectangular region is mapped into a circular region in xy plane. That is x square plus y square equal to a square. Now, our limit is theta is 0 to pi, r is minus a to a. Okay, there can be minus pi to 0 or 0 to pi, whatever it is. Now, z is square root of a square minus x square minus y square. It becomes a square root of a square minus r square. Now, d of xy we have to change it to r theta. Otherwise, the limit we have taken. Now, our area, the area we are trying to find, here the height is a square minus r square. A square minus r square square root. There will be little more to it. dr theta. Now, if I had a cuboid, then there was a height, and height is constant in the cuboid. Consider that height is h, then it is h into d of xy. Here height is square root of a square minus r square. D of xy that I have to convert into d of theta r. And limit is theta is 0 to pi and r is minus a to a. The limit shows that on theta r plane, volume is height into area on the theta r plane, and this area is rectangular. This is what we wanted. This is analogous to the cuboid. Okay, now d of xy I can write as d of xy by d of theta r into d of theta r. Simple multiplication. Now d of xy by d of theta r is d of xy, means d of area in xy. D by d of theta r means d of area in theta r. If I take a rectangular area in theta r plane, and there is one unit change in rectangular area of theta r plane, brings how many unit of area change in xy plane? D of xy plane by d of theta r into d of theta r. Now d of dy by dx, one unit of change in the x brings how many unit of change in y? Dy by dx, d of xy by d of theta r, one unit of area change, dy by dx, one unit of length change, dxy by d theta r means one unit of area change in theta r brings how many of unit area change in xy plane. They are connected. In theta r plane there is a rectangle, then correspondingly there is a circle in xy plane. This is why we change. If in this rectangle I make one unit of area change, how much this circle area will change? It will shrink or it will grow. Means they are connected to each other with a formula that x equal to r cos theta, y equal to r sin theta. That is this is the way r theta plane and xy plane are tied to each other. In xy plane there is a circle, correspondingly there is a rectangle in theta r plane. This circle is minus a to a in x, and y it is minus a square root of a square to square root of a square minus x square to minus square root of a square minus x square. It is a circle. Similarly, that is mapped to a rectangle here, and where theta is 0 to pi and radius is minus a to a. Okay, now if that is the case, in this rectangle, if I draw a rectangle, any rectangle, and if I make one unit at any moment when theta equal to theta and r equal to r, at any moment if I make one unit of area change, at that moment how many unit of area change I see in xy plane? Dxy plane by d theta r plane, same as dy by dx. One unit of change in x brings how many unit of change in y? Dy by dx. Similarly, dxy by d theta r. Okay, I won't go into the details because many times we have talked it. It is same as if I take any point, if there is a there is any point here called theta comma r, and similarly that point here, corresponding point here is x comma y. From origin, if I connect, take any point on theta r plane as theta comma r. That point will be matched on the xy plane at x comma y, or r cos theta comma r sin theta. Okay, take a vector from origin that is called p vector. So dxy by d theta or dp by d theta cross dp by dr. Okay, many times I have talked about it. Please watch Jacobian or other video where we have talked about how it comes like dxy by d theta r as dp by d theta cross dp by dr, where p is a point on xy plane. Means d of xi plus yj by d theta cross d of xi plus yj by dr. That is the concept of dxy by d theta r into d theta r. We started with z into dxy. Dxy change into dxy by d theta r into d theta r. D theta r, that is the numerator. Since they are orthogonal, I can write as d theta into dr, d theta dr. And here dp by d theta cross dp by dr. P is xi plus yj. X is r cos theta and y is r sin theta. D of r cos theta I plus r sin theta j by d of theta cross d of r cos theta I plus r sin theta j by d of r. If someone does this cross product, it will come as r, simple r. Okay, cross product I and that side j. D of r cos theta by d theta will become d of minus r theta, and that side j, that will become simple sine theta. Then it will become I j cross will be k, and then j I cross will be k. Whole cross will come as r k, r and k vector, d theta dr. And here we have z as a square minus r square. Whole came as r into a square minus r square. Okay, and then I have not taken vector into the consideration. Next session will be vector. Anyway, r a square r into square root of a square minus r square dr d theta, where r is from minus a to a, theta is from 0 to pi. This is the net volume of a sphere in theta r plane. I converted x, y to theta r because life is very simple and it is matching the cuboid. Cuboid is in xy plane, the area x is 0 to w, y is 0 to l. Here theta is 0 to pi and r is minus a to a. If I settle it down more, then it will become theta will be 0 to 2 pi and r will be 0 to a. It is exactly what we had. Now the z there, z was a constant value when there was a cuboid. Here z, height is variable with theta and r, that is r into square root of a square minus r square. Z is variable with different theta r. And then it is d theta dr. Certainly this is not a cuboid in theta r plane also. Because if it is a cuboid in theta r plane, z will be constant. Cuboid means there will be a rectangle region in xy plane and z will be a constant. That is cuboid. If there is a rectangle in xy plane and height is variable with theta and r, then height is certainly, it is not a constant. R square root of a square minus r square. If r is 0, then height is 0. If r is a, then height is again 0. Okay, when like that. So it is some different kind of 3D shape it is showing. So now r square root of a square minus r square. If someone does integration with r, it will come at a square minus r square to the power 3 by 2. Okay, into minus 1 by 3. Minus 1 by 3, then a square minus r square to the power 3 by 2. If someone differentiate it, then it will become 3 by 2. 3 by 2 into square root of a square minus r square into minus 2r. 2 2 gone, 2 2 gone, 3 3 gone, minus minus gone, and it will become r into square root of a square minus r square. So it is minus 1 by 3 square root of a square minus r square to the power 3 by 2 is the net integration. Now someone can substitute minus a to a, or 0 to a, 2 into 0 to a. Because it is fair, it is congruent. So 0 to a, 2 into 0 to a. Now 0 to a, if I place a in r, it is a square minus r square to the power 3 by 2. If I place r as a, it becomes 0. If I place 0, then it becomes a to the power 3. Okay, leave minus fundamental right now. It becomes a to the power 3 by 3. Then theta is d theta is theta, integration 0 to pi. Now it becomes pi a to the power 3 by 3, and 2 I had kept outside, 2 pi a to the power 3 by 3. We had calculated this for the top hemisphere. 4 pi a to the power 3 by 3 is the volume of a sphere as far as pseudo multivariate calculus is concerned. Pseudo multivariate calculus, it will be more clear once we take this differentiation. But anyway, this is how the integration is. If someone is trying to calculate volume anything in three dimensional in multivariate case, start with the simplest case and start with double multiplication of two item or division of two item, and see if numerator is dependent upon denominator. Quickly convert the division into differentiation. And if there is a multiplication of two items and one item is dependent upon another item and another item is independent, quickly convert this multiplication into integral calculus, integration. And then whatever the independent component is, see where independent component in three dimension is the area one point to another point. Break this area into two parts if it is x and y, and means it is two independent components, and then anyone can solve it. Anyway, we will proceed now in vector fundamental. Same thing, how we can proceed in vector concept. So vector concept in the sense, if I'm trying to find a volume of anything, volume of a cuboid, then this is x-axis, this is y-axis, this is z-axis. Cross product of x-axis and y-axis gives the area vector of this xy plane. Dot product with z-axis gives the net volume. Net volume is z. If height is z, then zk. Dot product with in bracket xi cross yj. That is the volume. Zk dot product and in braces xi cross product with yj. Xi means x is the amount, I is the unit vector. Cross product y is the amount, j is the unit vector. If someone cross it, dot product with the z is the amount and k is the unit vector. That also gives the volume of a cuboid. Then we will proceed in this, that how we can proceed through this fundamental. The volume is zk dot cross product of xi plus yj. What we are trying to find, the volume is that if this is the sphere, if this is the sphere and it is kept on xy plane or it is midway, then the volume is whatever the we have the area vector on this xy plane, that is xi cross yj dot product with zk. That is the volume. Or someone can think about the volume. If I take area vector at this surface, area vector at this surface, okay, multiplied by the height vector, that will also give the volume. That proof is not available in any of the book, that the volume of any 3D is xy plane area vector into z vector. That is possible. But surface vector multiplied by the height vector, that also gives the volume. Because after all, if I'm trying to find volume of this shape, then whatever the surface area is, okay, and then surface area multiplied by the height will also give the volume, or surface area multiplied by the height, both sides. I talk surface area on this side multiplied by the height, or surface area this side multiplied by the height. But this will work only in the vector. Very straightforward, we cannot do through algebra. We have not introduced vector and we were doing all the things through algebra only. Now we will jump into vector, and then we will see that surface area of a shape into height also brings the volume if it is a vector. Mind blowing. This proof is not available in any of the book. Someone can go and check. Anyway, we do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.